Okay, question 7. Standard piece of A4 paper is usually 0.08 millimeters thick. What is 0.08 millimeters thick? Written in meters in standard form. Circle your answer. Now, we've got quite a small measure here for this piece of paper. So this is really thin. Okay, you know, it's such a small fraction of a millimeter. And then they want us to change it into meters. Now, if you think about it, if this is just such a tiny fraction of just a single millimeter, it's going to be an even smaller fraction of a meter. Okay, so we're going to have more zeros after that decimal point. Okay, so we're going to have an answer here probably with a big negative power. So it could be -4, could be -5, could still be just -3. Okay, but we'll see now when we work this out. Now, key to remember information here, of course, 10 millimeters is 1 centimeter. Okay, and then of course 100 centimeters in 1 meter. Okay, and what I would do is to change this into meters, I would first of all change it into centimeters. Okay, in terms of centimeters. So 0.08 millimeters. We'll change this first of all so that it's in centimeters. Now, if 10 millimeters are in a centimeter, okay, we would need to divide this by 10 to see then what that is in terms of centimeters. It becomes an even smaller number, and divide by 10, every number shifts to the right by 1 place. We end up having 0.008, okay, centimeters. And then we'll change this then into meters. So because there's 100 centimeters in a meter, okay, remember now in terms of a meter, it's going to be even smaller decimal. In terms of a meter, in terms of a centimeter it's really small, but in terms of a meter it's going to be even smaller. So we're going to be dividing again, right, making this smaller. And because there's 100 centimeters in a meter, you divide by 100, and this time the digits move 2 places to the right. You end up having 0.00008, okay, meters. And in standard form then, okay, what we tend to do is the easier with standard form is to think about moving the decimal point. So to get the value in standard form, you need to have the number between 1 and 10. So 8 would be appropriate. Let's see how many places it moves. 1, 2, 3, 4, 5. Okay, so it moves 5. So it'll be times 10. Because it's a really small number and the point's moving to the right, it's going to be -5, right, to represent the really small number. So that's what we want there. Part B, it says a piece of card is 1 millimeter thick. Stack of these cards, pieces of cards, is 3 times 10 to the -2 meters high. Calculate how many pieces of cards there are in the stack. Now, again, they're comparing different units, millimeters to, and then we've got meters then, in terms of the height of these stack of cards. Now, what I'd probably do to make it easier, I'd probably try and write this in terms of millimeters to see how many we've got. So 3 times 10 to the -2 meters is just equal to 0.03, isn't it? As a standard number, as a ordinary number rather. Okay, so we go away from standard form, 0.03 meters. All right. Now what I want to do is change this into millimeters, ideally. Okay, so first of all we change it into centimeters. Okay, so we times by 100. Okay, because if we've got 0.03 meters, to see how many centimeters there, we need to times by 100. 100 centimeters in a meter, times that by 100, you get 3 centimeters. And then to change into millimeters, okay, because in the centimeter there are 10 millimeters, we're going to times that with 3 then by 10, so you get 30 millimeters. Okay, so that's how high this stack of card is, 30 millimeters. Now, one piece of card is 1 millimeter. Okay, so then if we've got 30 millimeters, we must have 30 cards. Okay, and in part 2 then, what assumption have we made in answering B part 1? Now, the only thing I could think of, and then obviously I checked the mark scheme on this, right, to double check, is that when you stack these cards, if you think about it, sometimes with cards, you can have gaps between them. Okay, maybe air gets in, maybe it's slightly bent. Okay, So in this case here, right, the assumption is that there's no gaps between the cards, that they sit perfectly on top of each other, if that makes sense. So that's the only thing that really that we could say here. The other thing you could say is make sure the cards aren't folded, because if they were folded, if a piece of card is folded, and it suddenly goes from being 1 millimeter thick to perhaps being 2 millimeters thick. You know, so anything like that. But what I'll write here is ensure that there are no gaps between the cards.